Hi, in this video, I'm gonna talk about Comprehensive Abaqus Package Chapter 10, Buckling and Post-Buckling Simulation. How to ask your video-related questions. Don't hesitate to ask any questions you might have about the explanations presented in this video using the comments below. We will try to answer all questions regarding the video details in the comments below. New Abaqus users who want to develop their modeling skills faster in their projects can request user-oriented online and offline services. Subsequently, we offer a step-by-step guidance, tutoring, and consultancy regarding their problems. The online service includes online sessions, and the offline service includes creating special tutorials. In addition, a combination of the two can be requested. This is the table of content for Chapter 10. And what is the source of error in calculating a much smaller peak load compared to the buckle analysis? The answer to this question is the value of the imperfection coefficient. For our structure, which is 1 meter height, 0.1% imperfection is too large, and it must be decreased. And in the next simulations, as I decrease the coefficient, so we will obtain larger values of buckling force, and this is correct. And also it matches the theory. So you cannot use every value of imperfection coefficient which you want. If you use large values, so the accuracy of calculating the buckling force decreases, and you cannot predict the behavior of the structure correctly. And here I want to talk about a paper about this. Papers. Experimental and numerical analysis on the structure behavior of cold formed steel beams. This is a good paper. I will send it to you. And here they have talked about buckling analysis, and also the and introducing imperfection. Analysis. This part. Each finite element analysis was carried out in two steps. Firstly, an eigenvalue elastic buckling analysis was performed to establish the buckling modes or eigenmodes which were observed in the test, and consequently to determine the geometric imperfections to introduce in the model, like what we did. Okay, first they use buckle step to calculate the buckling modes, and then they will introduce it or introduce them to the main analysis. To determine the geometric imperfections, after knowing their effects on a structural response of this kind of beams, the following maximum values were chosen for the local, distortional, and global geometric imperfections. H divided by 300, 0.4 multiplied by T, and L divided by 750. respectively. Then a general geometrical and material nonlinear static analysis with imperfection, or GMNIA, was undertaken with the purpose of simulating the structural behavior of cold formed steel beams under bending. Under bending at ambient temperature. The nonlinear geometric parameter NLGOM was set to deal with the geometric nonlinear analysis, namely with the large displacement analysis. So here they have introduced 3 buckling modes to the structure. Local buckling mode, distortional, and global. Okay, and but please notice that Abaqus doesn't give us the buckling modes with their names. You should understand them from the mode shape, from the figure, from the figure of the or configuration of the mode shape. You should understand that it is a local buckling mode, or a distortional buckling mode, or a global buckling mode. For example, let me check it first. Very good. Very good. For example, here for such I-beam, or if I check the slides, check the shape again, yes, that's it. The final shape is something like this. The final shape. And here we have bolts. Okay, in some places we have bolts. For global buckling mode, it's something like this. For example, this construction line will be changed to this. Okay, the whole structure is deformed, and they are like this. This is for global buckling mode. Okay, global buckling mode. Global means that the whole structure deforms. The whole structure. For example, here the whole structure is bending. It is a global buckling mode. What is the distortional? In the distortional, we have the structure again and for the distortional, it is something. For example, it has this kind of distortion. For example, this kind of distortion. Okay, this is the distortional. That's it. Distortional. And what about the final one, local? For the local, we have the structure again. And I told you here we have bolts, okay? We have bolts. And in the local buckling mode shapes, these places buckles and they have deformation. For example, in this manner. Only local. They are local. Local deformations. So we have a local buckling mode. So you should understand it. You should understand the type of buckling mode from its shape, from its configuration, and then maybe you ask me that, for example, we request for 20 modes, and we know that the first 10 modes are accurate. And for example, we find that we have in the first 10 modes, we have 3 local buckling modes and 3 distortional buckling modes and 4 global buckling modes. So which of them must be used? You must use the first mode of each type. For example, mode 1 is global, so we choose it for global. Mode 2 is also global, we don't choose it. Mode 3 is local, we choose it as the first local buckling mode. Mode 4 is global again. Mode 5 is the first distortional, so we choose it as the first distortional buckling mode. So we have one mode for each of the types of buckling modes, and then we can do the analysis. For example, mode 1, mode 3, mode 5. When you want to define imperfection, you write 1, then in the next line 3, then in the next line 5. That's it. It's local buckling. this is the answer to your possible question. And here they have mentioned the coefficients. Here they have mentioned the coefficients. For example, as I told you, you must write it like this. A star imperfection no. Here we write 1 and 3 and 5. And here it is written h divided by 300. You must calculate it. You must calculate its value. For example, it is alpha. It is h divided by 300. You must put its value here, okay? You must put its value. And also 0.4 multiplied by t. 0.4 multiplied by t and L divided by 550. Excuse me, 700. L divided by 750. That's it. Here I want to introduce you the final project of this course. It is from Applied Ocean Research Journal and it's for 2021. As you can see, it's a very new paper and its topic is experimental study on the compression mechanical behavior of steel pipes with mechanically induced pitting corrosion. The analysis of corroded pipes is one of the hot topics for the civil engineering and even mechanical engineering. And also their buckling behavior, bending behavior, torsional behavior, all of these are hot topics. And in this paper, 10 pipes are analyzed. The first one is intact. It doesn't have any pitting. It doesn't have any corrosion. And the 9 other specimens, they have corrosion. They have corrosion like this. They have corrosion like this. We have created these holes ourselves. And you can see different patterns for corrosion. You can see different patterns for corrosion, and they have defined a lot of tests for each specimen, and finally they have done some simulations. Why it doesn't go down? It's making me angry. It's because of Abaqus. It's because of Abaqus. And here you can see the simulated shape under axial force. And the other one. This paper is very good. This paper is very good. And also I have some ideas to develop it. And as it is a hot topic, and here let me find, I found. A stress distribution law of pitting area. They have used Abaqus 6.14 version, and also if I read here, the circular tube D30 T6E is considered as an example for comparing the numerical and test results. The initial defect is realized by introducing the first order buckling mode. The initial defect size is the measured defect of the specimen. As shown in the figure, the load displacement curve, failure mode, and deformation diagram of the specimen obtained by a numerical calculation are in good agreement with the test results. Therefore, the numerical simulation methods and results are considered credible. And here they have used the first order buckling mode. They have used the first buckling mode to do the analysis. And also they have mentioned the element type. It is C3D8R. And even I think they have mentioned the element size. Mesh size is 5 millimeter. Okay. And creating the models are complex because the holes are blind. If you see here, the shape of the holes from top view, you can see that the holes are blind. They are not through the thickness completely. So creating such holes is a little complex. But I have taught you how to do this in chapter 5, which was related to meshing and partitioning. And I have taught you every tool which is needed to do this analysis successfully with less than 10% error for the load displacement curve. And it's you can do it. And in the next sessions I will tell you which specimen you should recalculate. Which one? For example, maybe D40 T6E, for example, D40 T6E. Here, what they did, if I go back to the D30 T6E in figure 21. That's it. You can, for example, I can choose this one for you, as we have all of its results: the final shape, also the load displacement curve, and also they have provided all the needed data. And maybe yes, I select this specimen. this specimen D30 T6E, and is it completing? Not yet. That's it. Do you have any question? Also, the subjecting these kinds of pipes under the combination of bending and axial forces, bending moment and axial force can be very interesting, and some interesting curves will be generated, and I have done this previously. But as it is more complex, I don't want to give you it as the project, the final project. But it's a very good challenge. It can be a very good challenge. But and in the future, I will give you the description of the project, and also I will tell you the terms and conditions for doing the final project. It is optional. It is optional. It is optional, but I will tell you in the next sessions about it. It's optional. How to purchase packages or individual chapters. Each of the packages and individual chapters includes CAE, JNL, and IMP files, step-by-step tutorials with detailed explanations and investigation of the results, slides and reference papers, and standards. Packages specifications and payment details are provided in the video description. Also, you can pay the cost of the packages in 2, 3, or 4 installments according to your budget or income. In the future, updates will be provided for free for everybody who purchases each chapter or each package. The cost of each chapter or package will increase after each update for new buyers, but those who purchase the package would have endless access to all the upcoming updates. This will make the content up to date for new needs and new problems which must be solved via FE simulation. You can contact us using Telegram or WhatsApp, or you can send email to us. We can have one-on-one tutoring on the AnyDesk WhatsApp, and we can make special tutorials to your order. We can conduct high-quality simulations for your thesis exercises and industrial projects. We offer support in writing the modeling and result discussion part of your thesis, and we have consulting services for MSc PhD positions or job interviews, and we can help you to prepare the presentation of your simulation works. Now I want to suggest you several related videos of our YouTube channel. Thank you so much for watching this video. Have a good time. Goodbye.